Hello and welcome everyone. So I'll be explaining problem B of recent Codeforces round 746 division 2. In this problem, quite interesting problem, and the observation is also quite interesting for this problem. Problem number B.Hemose and Hemose shopping. Problem is straightforward. You're given an array of n integers. You have to sort that array into non-decreasing order. The numbers are not permutation. They are not permutation. I'm telling you again, and the values will consist from 1 till 10 to the power n. So basically, you're given an array consisting of n integers. You have to sort the array in the non-decreasing order. Now, you are allowed to make only one type of operations, as many as times you want. You just have to say whether you can sort the array or not. The operation is that you will choose two indices I and j, and the difference between that indices, difference meaning absolute value difference, should be at least x. At least x. This amount of distance it should be. Okay, so like if I say that this is the range of the array, let's create a box and try to explain you guys. It might happen that I minus j, like 1, 2, 3, 4, 5, 6, 7. So like you will choose two indices I and j. Their absolute value should be greater than or equal to the given value x. Now this x is the value that you're gonna take input, okay? And if this condition satisfies, you can only swap then ai and aj. Okay, now yes, like the answer is easy. Like you just have to say that you just have to output yes or no, whether you could actually successfully sort the given array or not by doing these operations as many number of times as you want. So the main observation is that instead of thinking I minus j less than or equal I minus j greater than or equal to x, instead of thinking the at least value, you will try to think this problem that what is the maximum range that I can take. Okay, that's the most important part here. That is the most important part here. The observation, they're just like deceiving with this condition. What you need to understand, yes, this is important, but it is actually deceiving sometimes, because if you closely analyze it, you will see that at least x, yes, this is important, but the most important way to go through to solve this problem is to think about it. What is the maximum amount of difference that I can make in order to sort the two indices? Now that would be, in a typical array, that would be like the nth minus the 1th, right? If n is equal to 7, then it would be like 7 minus 1, 6, or in a typical way it would be n minus 1. That would be the maximum number of way, right? Now, what I thought about this problem is that seven minus 1, as I've told you, that you will try to know what is the maximum difference that I can make. You know the maximum difference that you could make. It's the nth minus the 1th. Okay, the last index minus the first index. Now the key observation is you'll sort the array in a and you're gonna store that in a temporary array, and then you're gonna compare with the given array, and you will see which of the arrays are in order and which of the arrays are not in order. If the array's value itself are typically in order, then you don't have to do anything with that. You don't have to swap or anything. If they are not in order, then you know that yes, this number, I have to do something. I have to do some operations such that it goes to its own place. Now, what is the best way to do that? What is the best way to do that? Think about it. If I say I have an array, let's take an example here. Let's take an example 5, 1, 2, 3, 4. Okay, 5, 1, 2, 3, 4. If the array itself is like 5, 1, 2, 3, and 4, and I know the exact order 1, 2, 3, 4, 5. Now, think about it. If like 1 is not in its own place, right? 1 is not in its own place. So we're dealing with this position, let's say, and I'm saying that okay, 1 is not in its own place, so I have to drag back this 1 in this position. Now, what is the most efficient way to do that? You will say, what is the most farthest way to do that? The farthest way to do that is to think about it. What could be the farthest way that you could transfer this 1 to its own place? I could swap this 1 with this last index. In that sense, I'm maximizing the swapping difference, right? I'm maximizing the positional distance. Think about it. I'm maximizing the positional distance. I'm dragging this till the last, dragging this 1 to the last. So 1 comes here, and 4 comes here, and swap that. I'm gonna swap it, and now I know the 1's, this value, its real position is here, and I'm also maximizing this part. So I will always, are you getting that? What I'm gonna do is, for each value, I'm gonna try to maximize the swap up, maximize the distance of the swap. And the only way to do that, or the best way to do that, is to drag that position, drag that value to either the first position or to the last position, depending on what is the absolute value is. And by doing that, after you drag back that value which is not in its own position, and you're dragging that either in the front or in the back, depending on the absolute value, if you could do that, you are actually maximizing the absolute value position, such that you don't need such that you are dealing with the fact of greater than the absolute value should be greater than or equal to x. Okay, it doesn't matter. I'm always trying my best to maximize the swapping distance, and the only way I can do that is to make either that value to the front or to the back. And after you position that value, like for this case, for 1, I had to make it to the back, not in the front. If that value would have been 3, I would have taken that 3 to the front, not to the back, because from the back till that value's position, it's smaller than the front. So in case of 3 is not in its own position, so what you will do, okay, take it to the front, maximizing the swapping absolute value, and then when 3 comes in the front position, then take it to its final position, which is the third position. Now, the only way to do that, so I hope you're getting what I'm trying to make you understand. That's exactly what we're gonna do. We're gonna place the unmatched value to either the front or the back, and when we get there, we know that yes, from that I'm always trying to maximize the swapping absolute value distance. The way I'm going to implement it is let's take it to the code part. Yeah, we're gonna take the n and x, take the value, we're gonna sort that to just, you know, comparing with the real absolute position. If that value temp is actually referring to the sorted array, so I have to sort it. So after sorting, when I compare, they're not equal. Okay, this is not equal, so I have to deal with something. What will I do? I will only check whether from that position, which one I will only take whether from that position to the absolute value from the back and the absolute value from the front, which of them is the maximum distance. I'm going to take that maximum distance, and then I'm going to compare what is that whether that maximum distance, by taking either to the front or to the back of that value, is greater than or equal to x or not. If it's not x, if it's not greater than or equal to x, then you know that there's no other way that I can swap that value and take it to its final position or its appropriate position. And that's exactly what we did in this part. We're comparing that maximum value. Think about it, I and then n minus I plus 1, as it's actually zero base indexing. Anyway, that maximum distance, remember these two values are what? From that position to the back, from that position to the front. Okay, from that position to the back and from that position to the front, taking the absolute value just like the problem said, I minus j, and then checking out of these two absolute distance, which one is the maximum, and then compare with that maximum with the x that I'm given. If it's greater than or equal to x, then yes, it's possible to swap that into its final position. If it's not, immediately cross over and cut it out, and the FL is equal to 0, which is ultimately gonna give us the answer no. Otherwise, it's gonna give the answer yes. Ultimately, S meaning that every value is in its final position. So yeah, I hope I made you understand that. And yeah, if you have enjoyed the video, please don't forget to like, share, and subscribe. It helps me a lot and encourages me to make more and more content and videos for you guys. Yeah, till next time, goodbye.